And welcome to Cambridge Chemistry with Sarwat Ahmed. Be sure to like the video and subscribe it. Really helps the channel to grow. Today I will solve October-November 2023 507041 paper. And I will explain that how to solve this paper. A student investigates the rate of reaction between calcium carbonate and dilute hydrochloric acid. Figure 1.1 shows part of the apparatus the student uses. The student determines the rate of reaction by measuring the volume of carbon dioxide produced in a fixed time. Name the apparatus X, that is the conical flask. The student has incorrectly positioned the delivery tube in the apparatus shown in figure 1.1. Complete figure 1.2 to show the correct position of the delivery tube. The rest of the apparatus the student uses to collect and measure the volume of gas produced. To measure the volume of gas, we used gas syringe, graduated gas syringe. So this is the delivery tube. This is the wrong position, should not dip in the solution. Delivery tube should not dip in the solution. So this is the correct way to draw the diagram. This is the gas syringe, graduated gas syringe, and delivery tube should be above than this solution. And the student collects 48 centimeter cube carbon dioxide during the first 2 minutes. Calculate the mean rate of reaction in centimeter cube per second during the first 2 minutes. This is the rate equation is equal to volume of gas over time. So volume of gas is 48 centimeter cube, while first 2 minutes, that is the 2 into 60, and this is equal to 0.4. Mean rate of reaction is 0.4 centimeter cube per second. Question number 2. Hydrochloric acid is neutralized when it is added to aqueous potassium hydroxide. This is the chemical equation, KOH plus HCl. Hydrochloric acid, this is potassium hydroxide, to form potassium chloride and water. The reaction is exothermic. All neutralization reaction, please keep it in mind, all neutralization reactions are exothermic. All neutralization reactions are exothermic. P is aqueous potassium hydroxide, this is P, and Q is 2.24 mole per dm cube of hydrochloric acid. This is the concentration. Mole per dm cube is a unit of concentration. A student determines the concentration of potassium hydroxide in P. The student does 6 experiments. Step 1. Uses a volumetric pipette to add 25 centimeter cube of P to a plastic cup. Uses a measuring cylinder to add 20 centimeter cube of distilled water to the plastic cup. This is the plastic cup. Student pipette to use pipette and volumetric pipette to measure 25 centimeter cube of P into this plastic cup. Okay, 25 centimeter cube P. Now uses a measuring cylinder. So this is the measuring cylinder. This is the measuring cylinder, graduated measuring cylinder. Graduated measuring cylinder to add 20 centimeter cube. So 20 centimeter cube of distilled water to this plastic cup. Step 3. Stir the mixture in the cup with a thermometer. Thermometer is placed like this. Thermometer is placed like this and stir with the thermometer and record its temperature to the nearest 0.5 degree centigrade. Step 4. Uses a burette to add 5 centimeter cube of Q to the plastic cup. Now use burette. So this is this is the burette. So use burette to measure. This is the burette. Use burette to add 5 centimeter of Q Q is the hydrochloric acid to the plastic cup. Again to the plastic cup. Record the highest temperature reached. Step 6, empties the plastic cup and rinses it with water. Repeat step 1 to 6 using 5 different volumes of distilled water and Q, so that the total volume in the cup is always 50 centimeter cube. The student results are in the table. Volume of P 25 degree centigrade, 25 centimeter cube, and volume of water is 20, and volume of Q is 5 centimeter cube. So initial temperature of P is 424 degrees centigrade, and final is highest temperature reached is 26 degrees centigrade. So this is the rise in temperature 26. So how to calculate 26 minus 24 is equal to 2. So this is the initial temperature. So next temperature is, initial temperature is 24.5, and you add student add 25 centimeter cube of volume, 10 centimeter cube of Q, and you know that here he mentioned over here that volume of distilled water Q, so that the total volume in the cup is always 50 centimeter cube. Look at here, 25 plus 20 45 and plus 5 50 degrees centigrade. So if it is blank, so we fill it with 15, because 25 and 10 is 35, and 35 plus 15 is 50 centimeter cube. Similarly, 25 centimeter cube of P, 10 centimeter cube of water, and 15, 25, 10, 35, and 15, 50. So all volume is equal to 50, should be equal to 50. So 25 7 is 32, and 32 plus 18 is equal to 50 centimeter cube. Similarly, 25 plus 5 is 30, and 30 plus 20 is 50. So all volume should be 50, and this is 25 no water, and 25 and volume is equal to 50 centimeter cube. Similarly, this is the initial temperature. This is the initial temperature 28.5, and minus final minus initial, we get 4. 25 31 minus 25, we have 6. 31.5 minus 25, 6.5, and 32.5 minus 26 is equal to 6.5. So in this way, 30, this is the not filled, and this is you have to fill this column. So you know that 33 minus 26.5 is the 7.5. 33 and 26.5, 12. So this is 6.5, sorry, this is again 6.5, not 757, this is 6.5. This is 6.5. So parts of the thermometer used in the experiment 5 are shown in figure 2.1. The liquid levels inside the thermometer are missing. Complete figure 2.1 by drawing in the liquid level to show the initial temperature of P in experiment 5. In experiment 5 is 26. So fill it with over till this point, and the highest temperature reached in experiment 5 is 32.5. So this is approximately 32.5. Draw a graph of thermometer temperature rise against volume of Q on the grid on figure 2.2. You should plot the point 0.0 as there is no temperature rise when no Q is added. Plot the temperature rises and volumes of Q from table 2.1. Draw the straight line of best fit for the first 4 points. Draw a straight line of best fit for the last 3 points. So he is mentioned first 4 points and extend the line so they intersect. So these are the 1 2 3 4 points, and these are the 3 points. 4 degrees centigrade temperature rise, temperature rise 4 degrees centigrade, and volume of Q. This is the volume of Q is tens. This is for 10 centimeter cube. Q 10 centimeter is Q4, and 15 centimeter cube of Q is 6. 15 centimeter cube is thick. This is 6, and 18 degrees centigrade. So 15 to 25. So this is 16, this is 17, and this is 18. 18. This is 18, and at 20 degrees centigrade is 6.5. 20 degrees centigrade is 6.5. This is approximately 6.5. This is over here, and at 25 degrees centigrade is again 6.5. 25 is 6.5. So these are the, this is the line of best fit. Draw with the pencil, and these are the straight line, and we intersect these two lines. This is the intersect point. Don't draw like this. So this is, first draw this line till this, and this is the another line, and this line intersect with it, and this is 16.5 is the volume of Q. The point where the two lines intersect indicates the volume of Q that exactly neutralizes 25 centimeter cube of P. Determine the volume of Q where the two lines on the graph intersect. So this is the volume of Q, 16.5. Q is 2.24 mole per dm cube hydrochloric acid. Use your answer to D to calculate the concentration of potassium hydroxide in P. So first calculate the mole of hydrochloric acid. This is the concentration, and 16.25 is the volume of acid used, volume of Q used. So mole is equal to concentration into volume over 1000. Volume in cm cube always. So this is, we get 0.03 mole of HCl. 0.0364. By using mole ratio we get mole of potassium hydroxide. So here 1:1 ratio, and we the mole of H, this is HCl, and this is potassium hydroxide. So in this way we get mole of KOH. The mole of KOH 0.0364, and the concentration 0.0364. We use 25 centimeter cube volume of KOH. This is volume of P used. 25 centimeter cube of P exactly neutralizes Q. So the concentration is mole, or the concentration formula is mole over volume. This is concentration formula. Volume in centimeter cube multiplied by 1000 to form. This is how to calculate the concentration. So we have 0.0364 mole and 25 centimeter cube is the volume into 1000. We get 1.46 as the mole per dm cube. This is the concentration of potassium hydroxide in P. A measuring cylinder is used to measure the volume of water. Suggest why the volume of water in table 2.1 are not given to 1 decimal place, as it has high percentage error. So that's why volume of water in table 2.1 are not given to 1 decimal place. Distilled water is not, look at here, is not 1 decimal place like this. So this is not in 1 decimal place. State and explain why a plastic cup rather than a metal cup is used in these experiments. You know, metal cup is good insulator, good conductor of heat, so that's why heat transfer to the metal. So that's why plastic cup is better insulator than metal cup, because it absorbs negligible amount of heat. So that's why plastic cup is used instead of metal cup. Metal cup is the good conductor of heat and plastic cup is better insulator, is bad conductor of heat. So heat is not transferred to the metal cup, or heat is not absorbed by the plastic cup, but metal cup heat is absorbed by the metal cup. So that's why we use plastic cup. State why the mixture is stirred before measuring the temperature in this experiment, as water and mixtures are equally homogenized or distributed. So question number 3, a student investigates solution X and solution Y. Both solutions are colorless. The student does some test on X. Both are solution X and solution Y, and both are colorless. It means transition metal ions are absent. If solution is colorless, it means there is no transition metal ions are in X and Y. 3.1 shows the notes that the student makes about these tests. So over here notes are given. So these are the test of the cations and anions. So you can confirm the test from here. So first test is add drop of aqueous potassium sodium hydroxide to X in a test tube. White precipitate which then dissolves. Aqueous sodium hydroxide. Add aqueous sodium hydroxide to X in a boiling tube. So white precipitates which then dissolves. It means we can have zinc, aluminium. Zinc and aluminium cations are present because both are dissolved in excess of sodium hydroxide. Add aqueous sodium hydroxide to X in a boiling tube, warm the mixture and test the gas produced with damp litmus paper. This is the test of ammonium ion. You can confirm at the back. Ammonium ion and pungent smell of ammonia, no change to the litmus paper. No change to the litmus paper. It means warm the mixture, it means ammonium ion are absent. So if there is no change to the litmus paper, it means no ammonia gas is evolved. So solution X has no ammonium ions. So test of ammonium ion, but there is pungent smell of ammonia, no change to the litmus paper. Why no change to the litmus paper? So if pungent smell is produced, definitely will be the ammonium ion. Pungent smell of ammonia, it means this is test of ammonium, but why no change the litmus paper? So this is the question. So you know that might be litmus paper is not damp or not wet, so that's why, because acidity or alkalinity needs water. Add aqueous dilute nitric acid and aqueous barium nitrate to this is a test of sulfate ion. So white precipitates are formed. If white precipitates are formed, it means X contain sulfate ions, or sulfate ions are present in X solution. Part of the method for test 1 is missing. Describe the missing part of the method that is needed to give the observation shown. Add excess sodium hydroxide. Yes. So he only sodium hydroxide to X in tube and then excess. So white precipitate formed, which then dissolves in excess of sodium hydroxide. So this part is missing. The observation for test 1 are incomplete. Observation of test 1 are incomplete. State one other observation which is made for test 1. Colorless solution is formed, because when PPT is dissolves to form, so you have to write down PPT is dissolves to form colorless solution, dissolves to form colorless solution. So that's why this part is missing. So colorless solution is formed is another observation. One is the precipitate dissolves and form colorless solution. This is missing. Suggest why the ammonia produced in test 2 has no effect on the list. Moist blue litmus paper should be used. So there is no change to the litmus paper. It means litmus paper is not wet or not moist, because acidity, I have earlier told you that alkalinity and acidity needs water. So here water is missing. Moist blue litmus paper was used. Solution X contains 2 cations. Identify the cations in solution X which produces ammonia in the test 2. This is ammonium ion. Earlier I have told you. Explain why the student cannot identify the second cations in solution X from the test and observation in table. It is more difficult to determine second reagent with same reagent, as zinc and aluminum has same results. So identify the anion in X, that is sulfate ion, already discussed over here. This is the test of sulfate and this is the observation of sulfate ions. The student adds universal indicator to solution Y in a test tube. The universal indicator turns red. Identify the cation present. It means if universal indicator turns red, it means this is due to the acid. So the cation is in acid is hydrogen ion. So if HCl or H2SO4 all have hydrogen ion, HNO3 any acid which has H positive ions. The student adds a piece of magnesium ribbon to Y, hydrogen is produced. Suggest 2 observations the student makes. Effervescence of gas and magnesium solid disappears. So when magnesium react with Y, like any acid, HCl, magnesium chloride, this is solution, this is solid, this is aqueous. So effervescence of gas, this is gas. Effervescence of gas and magnesium solid disappears, because magnesium solid react with HCl to form colorless solution of magnesium chloride. So these are the 2 observations for this reaction. Describe how the student tests the gas. Show that it is hydrogen. Take lighted supplant in the gas jar. It will pops in flame with lighted supplant. So this is the test of hydrogen. You are very well aware of this test. Now next the student add dilute nitric acid and then add aqueous silver nitrate to Y. A white precipitate. This is the test of chloride ion. So you can confirm the test written at the back. Identify the anion present means this is the cation H positive and the anion is chloride ion. It means HCl acid is present in the Y. So the anion is chloride ions and cation is H positive. Identify Y, white precipitate of AgCl. You know, dilute nitric acid and then add silver nitrate. Then we add silver nitrate in HCl solution Y. What is formed? AgCl solid and HNO3 aqueous. So this is the white precipitate of silver chloride. Next question number 4. Ammonium sulfate is salt used in fertilizers. Ammonium sulfate is prepared by neutralizing dilute sulfuric acid with aqueous ammonia. This is alkali and this is acid. So neutralizing sulfuric acid, so process is titration is used here. Aqueous ammonia, I have earlier discussed that aqueous ammonia formula is NH4OH and sulfuric acid H2SO4. We neutralize this reaction by using titration. NH4 plus H2SO4 to form ammonium sulfate and water. So this reaction is carried out through titration, and in titration the common laboratory apparatus is pipette, burette and conical flask. So these are the three main apparatus used in this experiment, and aqueous ammonia is the chemical. These are the two reagents: ammonium hydroxide, aqueous ammonia, sulfuric acid, and methyl orange is indicator. No other chemical should be used. Your plan should include apparatus needed, the method to use, and you may not compulsory, but you can draw a diagram as well, like this. This is the diagram you must draw. If you draw like this is conical flask, this is burette, this is burette and graduated burette. This is conical flask, this is burette and this is pipette. This is pipette and mark over here 25 centimeter cube pipette, and this is beaker in which any solution like if ammonia aqueous over here or HCl. I am using HCl in beaker, which is 25 centimeter cube of HCl is taken with the help of pipette and in the conical flask along with the indicator methyl orange, which is red in acid and yellow afterwards when neutralization occurs. Wash the burette with distilled water and fill this with aqueous ammonia up to the mark from 50 centimeter cube to 0 centimeter cube. 25 centimeter cube of H2SO4 is taken. Sorry, we are using H2SO4, not HCl. H2SO4. H2SO4. Now this with aqueous ammonia up to the mark from 50 centimeter cube to 0 centimeter cube. 25 centimeter cube of H2SO4 is taken in conical flask with the help of volumetric pipette along with 2 to 4 drop of methyl orange indicator, which turns solution red. Add aqueous ammonia from the burette into the conical flask dropwise and swirl till the end point is reached. Note the volume of ammonia aqueous used to utilize the sulfuric acid. Repeat the above process by using the same volume of aqueous ammonia and sulfuric acid. Evaporate the solution mixture by heating till saturation point. Check the crystals with glass rod. Allow the crystals to cool at room temperature and dry the crystals in 3 folds of filter paper. Use all the piece of apparatus which you are using in this experiment. Like you are using burette, fill the ammonia in the burette, and sulfuric acid is taken in conical flask, written and with the help of volumetric pipette. This is very important to mention. Which turn solution red. Add aqueous ammonia to the burette, from the burette into the conical flask. Dropwise swirl till the end point is reached, which is yellow in color, because in aqueous this is yellow. Note the volume of ammonia aqueous used to neutralize the sulfuric acid. So all these things should be mentioned in this experiment. Hopefully you understood this ATP paper. So if you like this, please hit the like button.